Hello, my name is William. I am part of the product marketing team at GitLab. And in this video, I would like to speak with you about GitOps. This is how to do infrastructure automation using GitOps. If you are interested in learning more about GitOps and how it can benefit your organization, how you can adopt it, this is the right video for you. By way of brief introduction, we'll just talk about the landscape of software development. And as always, the landscape of software development is ever in a state of change. So if we take a brief look at where it's been and where it's at now, we can see that once upon a time, waterfall was a standard practice for developing software. And for many organizations today, they're still using waterfall software development practices, delivering software essentially like it's hardware, sequentially with long cycles, and it can take a long time before you get feedback. You can end up developing a product that your users don't even want because it takes you so long before you get that feedback. So in order to remedy these challenges, we started implementing agile software development, where we started making smaller and smaller changes with faster iteration cycles. This was a great step forward, but of course it led to another challenge, which was development teams were moving very quickly with small changes, and operations teams that were still doing manual infrastructure racking and stacking and provisioning were not able to keep up. So we ended up also adopting DevOps together with agile software development, so that with our automation, our development teams and operations teams collaborate together. And in the early days of infrastructure as code and DevOps, this was a great step forward where we started an entire world of automation. We had much more stability, much more speed and acceleration, better outcomes for our teams, and a lot more sanity. But of course, now we're shifting into a world of containerization, microservices, Kubernetes, and in this new cloud native world, the level of complexity exponentially increases. We now have dynamic environments that are always shifting and changing. They need to scale up to cloud world level scale under load and scale down with feature flagging, different people accessing your application with different profiles, get a different view. And with ever increasing speed of continuous delivery and ever smaller changes, people are adopting more and more smaller iterative cycles spread across a number of microservices. You have a great level of complexity with environments needing to keep up, and operations teams need to keep up with all of this cloud native complexity. So this brings us to the need for GitOps. So in this video today, I'll share with you what GitOps is, why GitOps is important. We'll look at some of the challenges with managing infrastructure in a modern environment and some of the benefits that GitOps can bring you. And I'll share with you how to do GitOps in your environment. So we'll look at how best practices for how GitOps teams are structured, and we'll look at maybe even some of the blockers to adoption, along with some of the technologies that you'll need to adopt in order to do GitOps in your context. So to kick things off, let's look at what is GitOps. Just like many technology terms, just like DevOps or cloud native or any of these terms that we use within the technology space, GitOps can have many, many different definitions, and people can use it differently. So what I would like to share with you is our perspective at GitLab on how we're thinking about doing operations via Git or GitOps. And so the way we're thinking about this is GitOps is an operational framework. And what it does is it takes the DevOps best practices that you use for application development. These are things like version control, collaboration, compliance, and CI/CD automation. And we're applying those to infrastructure automation. So I like to think of GitOps as DevOps for infrastructure as a shortcut. We'll dig into it more. A formula for thinking about DevOps, thinking about GitOps, is that it encompasses these three components. GitOps is going to equal infrastructure as code, storing your infrastructure in declarative code stored in a Git repository. We are going to be using merge requests as our agent of change. And we're going to be using CI/CD automation in order to do a reconciliation loop so that our infrastructure is always up to date with the correct state. So these are the three components, and we'll break them down one at a time. Infrastructure as code, merge request as a change agent, and our automation reconciliation loop. So to look at infrastructure as code, for most of this talk, most of this video, I'll just be using the term IAC or infrastructure as code. But really, this goes far beyond infrastructure. Sometimes we use the term X as code because this could be infrastructure, this could be configuration, this could be policy, this could be any type of operations work that you are defining as code. I'm wrapping up as infrastructure as code more generically, but this could be a lot of different types of code. And in the past, we did a lot of procedural code description, using procedural code to generate our environments. And that's a good place to start if that's where you're at or you've never done infrastructure as code before. That can work out for you. But ideally, what we want to use are tools and technologies that allow us to have a declarative set of code state. So we're declaring the desired state that we want for our infrastructure, and our automation tools are going to move it towards that state without us having to procedurally generate the exact steps need to happen. We're declaring a desired state, and our infrastructure is going to converge on that desired state. Of course, we want to store this in Git version control. So there's a lot of power in using version control in the same way that storing application code in version control is a big step forward. So too, storing our infrastructure code and our operations code inside of Git gives us all these power and advantages of doing version control. And of course, what we get for free when we do this is all of our Git tooling as the user interface. So all of our command line tooling, all of our developer tooling, all of our developer tools that allow us to interface with Git, of which a lot have been developed, and many, many engineers and software developers are familiar with this set of tooling. Now you can leverage all of that knowledge and all of that tooling to manage your infrastructure. So this is a very powerful component of doing GitOps. Next, we are going to be using merge requests as our agent of change. And so within GitLab, we call the concept of requesting to merge one branch into another a merge request. In other tools, it's called a pull request. But whether you use MR or PR, the power of GitOps is that you are structuring your branching strategy in such a way that your main branch becomes your production branch. Some folks call this default or trunk, or historically known as the master branch. But the idea is you have one branch is your main production branch or your main environment branch. For example, could be the branch for staging. And whatever is in that branch is what is going to be represented in that environment. So that way you can propose a set of changes, and when those changes get merged into that branch, that is the source of truth. And so that merge request or pull request becomes a gate. This gives you all kinds of powerful benefits when you adopt this type of GitOps. For example, you get all types of code review. That way, before that change goes live, you can have a set of peer collaboration and peer review on that code. You have a commenting mechanism, and very powerfully, you have a mechanism by which to do approvals in the MR before new changes go live, and you can gate who actually can enact those changes. So by using the MR as the gate, many people or anybody can propose a change, but for compliance purposes, you can lock down the set of people who can actually enact that change to a few set of people, and those are the people who have permission to merge to that main branch. This is a powerful mechanism of GitOps, is using merge requests as the agent of change. And finally, we're going to be using an automated reconciliation loop. So using continuous integration and continuous delivery in order to run as what we call a reconciler loop. So this could be done in many ways using many different tools. You could use an agent that lives within your infrastructure, or let's say within your Kubernetes cluster, something like a Kubernetes operator, and that could do a pull-based reconciliation where it's reaching out to your Git repository and pulling that configuration into your cluster. Or this could be an agentless push-based reconciler. You can have, in addition to your CI/CD loop your CI/CD running anytime you merge new code into the main branch. You can also just have a timer or a cron job or a CI/CD job or pipeline that just runs on a regular schedule. And that loop that's just running is just checking your environment, seeing has anything changed in the environment, has anything changed with the code. Let me go ahead and reconcile the environment to the defined state. We're gonna set, when anything is out of sync, we're gonna sync the infrastructure to match the defined state. And of course, within this model, changes are implemented completely in an automated fashion. So we're no longer doing any type of manual updates to our infrastructure. We've completely automated the process. So what does this flow look like when you and your team are actually using GitOps? It looks very, very similar to an application development team doing their application development. So here we have a main branch, and to start out a new change or new proposal to the environment, we would usually start with some type of agile planning, like creating an issue, let's say in GitLab issues. And this is going to be where folks can collaborate, define what needs to change, why it needs to change, what we're solving for, what bug we're fixing, or what new feature we're hoping to implement within our infrastructure. From that, we create a new merge request. This creates a new, what we would call a feature branch in application development. You may or may not think of that as adding a new feature to your environment or fixing a bug in your environment, but this branch is where you can collaborate, and you would commit your changes to that branch the same way that you would commit changes to application code. But in this case, it is the definition of our infrastructure. It's our infrastructure as code. Our CI pipeline is going to run on that code. It's going to do any type of automated testing, linting, any type of checks there. And then you may choose to do something called a review environment. A review app or review environment is a production-like environment. Think of this as a staging environment for every single branch. This is something you can do within GitLab, and potentially you can configure in other tools. But with GitLab as a feature, when you want to see what will this environment look like, I want to test an actual running environment before I go ahead and change my production environment, then I can use a review app to essentially get a staging environment for every single branch I create. This way, on this merge request, on this new branch, I can have peer review, I can have discussion, code review, and then I can have approval. This is a compliance mechanism. We can make sure that, for example, maybe I need someone from our security team to weigh in before changes, depending on what our compliance policy is. Or maybe just as a courtesy to making sure that the right stakeholders and the right folks have been able to review and approve the changes. And then, as I mentioned, using the merge request as that gate, when that code is merged back in with the people that have permissions to make changes in production, they merge the code back into the main branch. This automatically closes the issue, and our continuous delivery pipeline is going to run to then enact those changes and to update our infrastructure with whatever that new code change or that new change is. And then, of course, we want to monitor that application to see it running in production. This is what we would call the GitOps Flow, Git Flow, GitLab Flow. Looks like this. So some of you may be hearing in the video so far, and you're thinking to yourselves, gee, GitOps, it kind of just sounds the same as infrastructure as code. We've been talking about infrastructure as code for a long time. What's really all that different? Well, in some ways, yes, these principles and these technologies have been around for a while, and they're just now starting to come to fruition broadly. They're just now starting to become experimented with new technologies and to be codified into a set of best practices. So looking at some of the difference between doing GitOps and infrastructure as code is with infrastructure as code, your code may or may not be version controlled. There's no requirement for infrastructure as code to be version controlled. It could be a text file on your laptop, and maybe you just FTP that to your provisioning server, to your configuration server. There's not necessarily a mandate that it's stored within a version control, but with GitOps, that's a core element of the process. The same thing is where your changes in GitOps are enacted via merge request, and merge request is that gate. With infrastructure as code, code changes may or may not go through a approval process. They can, but that's not necessarily mandated. And then, of course, with GitOps, those infrastructure changes are automated, whereas, as I mentioned, in infrastructure as code, maybe you have some type of automation running. That certainly is a best practice, but it's not necessarily dictated. So when you say I'm doing infrastructure as code, it doesn't necessarily mean you're doing all these best practices. But when you say you're doing GitOps, it does mean these are these best practices that we've developed. So one way to think about it is that GitOps is infrastructure as code done right. So with that, now that we kind of have a base understanding of what GitOps is and how it works, let's take a look at why. Why is GitOps important? Well, let's look at some of the challenges and some of the benefits. So first, we'll look at these infrastructure as code, or what I would call X as code, any type of operations that you're storing in code. Just by doing that, you're going to get some benefits. So one of those benefits versus doing everything in a GUI-based configuration for your infrastructure or any kind of tooling that's not defined as code is all of a sudden now you get some self-documentation for free. So when you want to understand what's going on in your environment, a big challenge there is if the person who went and configured it in a GUI didn't go and write down what they did, it can sometimes be very, very hard to go and understand what is going on. How do I change this? How do I fix this? Maybe that knowledge lives in just that one person, and if they're out of the office or unavailable, then it can be very, very hard to move forward. But when everything lives as code, now it's very accessible. You can see exactly what is going on, and you get some self-documentation for free. This doesn't preclude the need to do some additional documentation, but this can live, for example, in a wiki or in a README right alongside your code repository. So that can also be collaborated on and shared broadly as one of those ways. Additionally, when, again, you want to share this knowledge, what did one person do within one tool, that can be sometimes hard to proliferate out to other folks. But when your infrastructure is stored as code, now it becomes very, very easy to share that. For example, let's say you've been doing some testing and some new configuration within your EMEA team, and they've developed some new efficiencies. And now you want to proliferate that out to, let's say, your Asia Pac and your North America teams. It becomes easy to share that knowledge across teams and even around the world because it's stored as code. Finally, let's say you just want to duplicate your environment. Let's say, again, your EMEA environment, everything works good. Not only do you just want to share that knowledge so that those other teams can take influence from it and enact it, but they want to actually go ahead and duplicate that in another region. This becomes very, very easy to duplicate. Or for any reason, if you just want to make a copy of what you've been doing, it's very easy to do when it's code. Which brings us to our next set of benefits, which is when you're not just storing as code, but when you have that code stored in Git version control, giving you the ability to roll back and roll forward to a particular point in time. Now all of a sudden, you get a whole nother set of benefits. So for example, you can tie your application versioning to your infrastructure configuration. Let's say you have an application or you have a service running, and that service has a really large memory leak. It's just consuming massive amounts of memory. And so this sprint, your engineers have gone in and they've really worked hard to close the memory leak and to just make the app run more efficiently. So it needs a lot less memory. Well, you can go ahead and deploy that, and now you would say, we need a lot less memory to run that service. So you can update your infrastructure configuration to say this service can run with a lower set of requirements. Well, what happens if there's actually a bug in that latest set of code that you've discovered, a user-facing bug that changes the behavior for the user? Well, now you want to roll back. But the problem is, if you just roll back to the old code or the previous version of the code that has a very heavy memory requirement, all of a sudden now you're going to crush your infrastructure, which has been adapted to the latest memory requirements. So by having this type of version control, this is just one scenario where your application version can be tied to your infrastructure configuration version. And those can move along in lockstep. If you're rolling forward or rolling backward with any changes, you can keep those in sync so that you can eliminate a whole category of problems that arise when they're out of sync. This is also a benefit, not just in collaborating with your application development teams, but also whenever you have any type of misconfigured infrastructure, right? When anything has come out, any type of mistake or bug, when it's easy to just roll back to the last known good config, this is a wonderful, powerful benefit of anybody who has ever started using infrastructure as code stored in version control. And of course, this lowers your mean time to recovery. So when your platform is down, when you've rolled out some type of change or something has happened, and you are now not servicing customers and users, to be able to roll back to that last known good configuration to then be able to troubleshoot in other ways, this is a really powerful mechanism that can really, really lower your mean time to recovery and get you up and running quickly so then you can do some further troubleshooting. Our next category of benefits using GitOps are related to the automation. So in particular, a huge benefit of doing GitOps is that you can just deploy faster and more frequently. So again, if there's some type of manual configuration or manual provisioning, I think many of us have been in an environment where you have some new application code, and before that application code can go live, you need to go and request your resources. And those resources need to go through some type of process before you can even get that server provision or that VM provision for you. This can be very, very painful. It makes it hard to do experimentation. It makes it hard to adapt and to adapt to your user base and go faster. And so when you automate that provisioning, when you automate that platform, you're doing GitOps, all of a sudden now your application developers can deploy a lot more frequently. They can go faster and deploy more often. Another benefit of this automation is any type of configuration drift. Whenever your infrastructure environment doesn't match your set configuration, we call this configuration drift. This is the power of doing infrastructure as code automated when you're doing GitOps. The notion here is maybe there's some type of failure within your environment and another piece of it needs to be brought back up again. Maybe there's a misconfiguration, or maybe even though it's not allowed, maybe somebody has gone in and done some type of manual tweaking for some reason. But that's bad because it's not documented. You don't know what's going on. You can't share the knowledge and all of these problems. So when your automation loop runs, the next time that pipeline runs or the next time the CD updates, it's going to update to the state, the canonical source of truth in your Git repository and overwrite any type of drift or changes so that you're always in lockstep with what is the canonical, known, documented, shared, and understood configuration for your environment. Finally, and possibly the most powerfully, as I talk to users who are doing GitOps, as I talk with industry analysts that are talking to practitioners all over the world, one of the most powerful reasons that I hear of why folks want to adopt GitOps is for the security and compliance benefits that come along with it. So when you're using Git as the interface, when you're doing merge requests as your gate, when you are doing this automation, all of a sudden you get a lot of security and compliance. I don't want to say for free, but it comes built into the system. So one is granting permissions and access to your environments. In a non-GitOps world, you would need to grant anyone who needs to make changes to that environment their own personal set of changes. And that can cause a lot of different problems. Who updated what when? It's tough to know. And you may have to grant permissions broadly to each and every environment or each and every part of your infrastructure. And that can be very, very challenging. Whereas if you simply have a set of automation, and that automation, that CI/CD, has the ability to update your environment. Now you have one service account or one mechanism that you need to grant permissions for, and now you can manage all of your permissions within your Git tooling. And so Git tooling already has a robust permission set, and so you can assign who has permissions to make proposals for which code branches, who has the ability to merge to which branch. Many people can contribute, but few people can be given access to actually make the change. So for compliance purposes, you can maintain a very, very tight set of compliance and regulations for who can make changes to your environment, but still maintain a broad set of collaboration. So there's a powerful set of permissions. Auditing all of a sudden becomes a whole lot easier. If you have manually configured environments, if you, anybody who's gone through an audit and has to go and look at what's been changed, where, who made the change, when you are trying to pull this information out of many different tools, this can, and then you have to normalize it to provide it to your auditors, this can be very, very frustrating. But when every change to your environment is made via git commit and git merge request, now you have a very, very nice historical log of what changed, at what time, and who made that change. And this is very, very powerful. It makes auditing very, very simple, relatively simple to having to deal with the broader mess. And of course, this change process compliance, which I've talked about a lot with this idea of having the merge request as the gate. You know, rather than having to have a change meeting and a manual change process, when you grant, you know, a set of approvers, these are the folks who are able to approve and who need to approve, and the set of groups that are able to approve a merge request, and these are the people that are able to merge to these branches. Now your change process is compliant per your policy. It's set per your policy via the technology and not needing a manual process. So there are many, many benefits. There's more than I could ever even cover in this video. And as the space evolved and as the technology is evolving and as best practices are evolving, we're seeing even more challenges and more benefits emerge. But these are just a few of the big ones that we're hearing about a lot, and some of the reasons why you might want to adopt GitOps or enhance the maturity of your GitOps practice. So having looked at what GitOps is and why it's important, now let's actually talk about that. How can you go about adopting GitOps within your current context? So to start out, let's take a look at what is the typical, or what I would call the best practice for your GitOps team structure. This is assuming a few things, perhaps that you are in a larger enterprise or mid-market company that has many, many development teams, and you have a lot of complexity to manage. So if you are, let's say, a new software startup, and there's 3 of you, and all 3 of you are engineers, and you all have access to the code, and you all have access to the environment, you can do all of that GitOps automation, and maybe that's your team, it's 3 people. But if you're in a large enterprise, and with many, many microservices, this is a best practice we're seeing emerge, and that's been emerging. That's been around for a while. This is the best practice that we're seeing larger companies enact, and this is the rise of the operations platform team. So in this guide here, or the way you might think about this, is in the top level there, these vertical slices, those represent the development teams that are responsible for a particular feature, or most commonly a particular microservice. So you can imagine in a microservices environment, you might have one team responsible for each service, or maybe a team responsible for a set of services. And that team, if they are a modern DevOps team, is going to be cross-functional, where you're going to have developers and quality folks and SREs all embedded together in that team. And a loose best practice that I've seen is the developers are 80% focused on feature development and 20% focused on infrastructure and operations. And so they're not developers who are completely devoid of anything that is happening with the operation of their service, but rather these modern development teams, they own their service, they own the pager. So when that service goes down, they're the ones that are responsible, and they understand. They can look at the monitoring, they can look at the operation of that service. They're not only developing, they develop the service, they operate it too. And this is a modern best practice for microservices teams. But of course, embedded within that service, you have one or several infrastructure and operations experts, some site reliability engineers. We call them the embedded SRE, site reliability engineer. And they might be, again, they're not completely focused. They're not the one person who owns the pager. They're not the one person who understands where the app is deployed, how it's deployed, or what the monitoring of that application code is. But they're more heavily focused on that. And they might be 20% focused on feature development. So they understand what's going on in the application. And so this delineation of roles within a cross-functional team is a best practice we've seen. And what we've noticed is that especially with modern platforms like Kubernetes, the way we think about GitLab, Kubernetes isn't necessarily a requirement. The way we think about GitOps at GitLab, you can do GitOps even without Kubernetes. You can store your infrastructure as code. You can use merge requests as your change agent. You can enact all of those changes in an automated fashion. And you can do that all without Kubernetes. And your platform team can serve up a platform as a service to your development teams. But when you start containerizing your applications and you start using Kubernetes, this becomes a lot more powerful and a lot easier. And especially for teams that are adopting Kubernetes, we're seeing the platform team emerge as a powerful team structure and for servicing this. And so the idea here is that your developer service teams, they don't need to understand all the bits and bytes of your platform. They don't need to understand all the bits and bytes of Kubernetes, all the ins and outs and the details of Kubernetes. And they certainly shouldn't be caring how many VMs I need to spin up in EC2 and what size instance. That shouldn't be a concern for them. They should be concerned with developing their application, their deployment pipeline, and that deployment pipeline should be mostly automated and owned by a platform team. And what's really powerful here is when this operations team can start to templatize this, they can spread best practices across the entire org. When spinning up a new service, they can give you a service template so that you can have a code repository and a pipeline that's all set to deploy into your Kubernetes cluster. And so it makes it very, very easy to spin up new services and proliferate out your changes. So the operations platform team, they tend to own the Kubernetes cluster, and sometimes they also own infrastructure. Although in some organizations, you may then also have a separate infrastructure team because no matter how many layers of abstraction, it always has to run on a server somewhere. And so these days, it could be an on-premises server. You may own the bare metal, and maybe your infrastructure team is literally still racking and stacking. But in this model, your developers are never waiting on that rack and stack, right? They have enough abstraction. The nodes that are running that cluster are abstracted away from the development team, so they just can get infrastructure on demand to power the needs that they have. But your infrastructure team, they may be doing it on premises. More common than not, they're going to be doing this in one or many cloud services, doing multi-cloud and hybrid with on-prem and cloud services. And so the platform team may be running the infrastructure, or you may have a separate infrastructure team that's providing and managing those nodes to the cluster. And then that operations platform team is as responsible for serving that platform as a service to the development teams, templatizing things. There's a lot of different ways to structure your GitOps teams. Depends on the size of your organization. But this is a very, very common pattern that we see over and over again in many large organizations. This is some of the best practices that they've adopted, folks that have been successful with GitOps. Now, of course, we can't talk about GitOps without talking about the tooling. And what are some of the technologies and the tools that you will use when you're implementing GitOps? Now, this is not an exhaustive list. There are so many sets of tools that I haven't even mentioned here. Agile planning tools, of course, are a big part of doing GitOps, but not necessarily core, so I haven't included them. We've talked about monitoring tools, and I haven't talked about any type of application or infrastructure or cluster monitoring. So this is not an exhaustive set, but to enact these core set of capabilities, these three components of GitLab, infrastructure as code, merge requests, and CI/CD, this is the type of tooling that you're going to want to implement. So, of course, first and foremost, you need a Git repository. And then additionally, you're going to need a Git management tool. So this is one sense in which we're a bit opinionated on how to do GitOps. We've definitely heard some folks may talk about, well, what's important is that you're doing version control, but maybe you could use any number of version control protocols. And that may be the case, but if you really want the compliance and security benefits of doing GitOps, you really need a tool that supports merge requests or pull requests. And that's not a built-in component of the underlying Git protocol. So you could just run your own Git server and just run vanilla Git. But the real power of GitOps comes in when you adopt a Git management tool, something like GitLab or GitHub or Bitbucket. Of course, you're going to need a continuous integration tool to do your automated testing. And you're going to want a continuous delivery tool. This could be something like using GitLab for continuous delivery, something like Spinnaker, or Weaveworks Flux, where it has a pull-based GitOps operation. Then, in addition to those, you usually want some type of configuration manager. So these are things like Ansible, Chef, and Puppet. With GitLab a lot, we see a lot of adoption of Ansible these days. And even in a world where you are all cloud native or almost all cloud native, although I haven't seen that in every organization, how did I hear? I heard one CIO describe it as they have a Smithsonian of technology. So they have a museum, they never ever update everything. There's always some kind of a mix. So because there's always some kind of a mix, you are still gonna want some type of configuration management that determines the configuration for servers. Or even if you have some type of cluster, unless you are using a managed Kubernetes service that manages your Kubernetes nodes for you, you're gonna wanna be somebody managing that infrastructure and need some kind of configuration manager. What we're seeing very, very powerfully used today are provisioning tools like Terraform, Pulumi, and even CloudFormation. And these provisioning tools go hand in hand with cloud native software development. This is where a lot of this automation comes in. And this is not just talking about the servers, whereas if you're containerizing your workloads, then a lot of your configuration is stored in your Docker file. You don't necessarily need a configuration manager, but you do need some type of provisioning, because that provisioning tool is not just, it's provisioning your entire infrastructure. So not just, let's say, your servers, but maybe your network configuration, your firewalls as well, any type of software-defined networking. Your provisioning tool can go out and provisioning the many different components of your infrastructure. So this becomes very, very powerful when you're doing GitOps. And then, of course, container orchestration, of which Kubernetes rules the roost. We've talked a lot about Kubernetes here. So with that, let's just take one last, a final look before we wrap things up at what are some of the challenges that you may encounter as you've looked at this. Maybe you're already doing some GitOps and you want to take it to the next level. Maybe you have gotten excited and you want to start enacting GitOps. What are some of the challenges you might face? Well, the biggest of all challenges, of course, with any technology change is always changing the culture. We know that new technologies can always make things easier, but for whatever reason, people don't change as fast as technology. And so what's really important to keep in mind is with any new, fun, exciting practices like GitOps is to have empathy and remain human about what you're doing, and realize that you're working as a team with other people, and you need to bring those people along. You need to adapt your culture. And so especially in many large organizations, operation engineers, sysadmins, folks that are running your infrastructure today, they may not be used to a developer-centric workflow. And so in order to use GitOps, this is a very developer-centric view of the world. So operations engineers that are also software developers, they love this because it's the tooling they're already set with. Or anybody who has a software development background and gets excited about infrastructure operations, they love this model of GitOps. But for some folks, this may be an adapting of skills. This may require some changing, a change in mindset. They're doing things in a different way. And so that cultural change is something to keep in mind as you move forward, and may differ per your environment. You may need to look at training programs. You may need to look at, for example, doing GitOps in a small part of your org and proving its success. We call that a lighthouse model. So when others in the org can see the lighthouse on the horizon, they know which direction to go. And when they've seen the success proven out first, then they're not as reticent to adopt that new technology. Another challenge you may face is you may not be at the level of deployment automation that's required to do GitOps. And that's okay. This is, in many ways, very, very bleeding edge. This is some technology that's been around for a long time, depending on your view of technology. A long time is very, very relative. But the idea here is that for many organizations, this is very, very new, on the cutting edge technology. And you may, before you go and adopt GitOps for your infrastructure automation, you may just need to first look at your CI/CD pipelines and your base deployment automation. Maybe you're doing a lot of automated testing. Maybe you're doing a CI, but you're not really doing CD yet. And that's a place to dig in, is to get your CD pipelines set up to explore that technology, to understand it, and then you can start to proliferate that out. Now, I definitely have seen organizations where the infrastructure team is a very sophisticated infrastructure team, and they actually decide that they really, really want to do CI/CD for infrastructure, and in some cases, adopt that even ahead of the application development teams. And sometimes that lighthouse team can be the infrastructure team to say, hey, look at this. We've adopted CI/CD. We've automated not just our testing, but our deployment and updates as well. And look at how we can have these environments on demand, and look at how we have this level of automation. And then application development teams say, you know what, this is pretty nice. I want that as well. Let's go ahead and do the work to build these DevOps pipelines for our application code as well. But wherever you're at, GitOps assumes you have this level of sophistication with your automation, and it may take some time to get there. That's okay. Finally, even though we love Git, even though operations via Git it makes a lot of sense, it's a very powerful mechanism. It's a world where a lot of us that have a software development background are just comfortable in, so that we can get started very, very quickly with a powerful set of tooling. Not everything belongs in Git, right? So just a few examples of some things that may or may not belong in Git, or you would have challenges with not having a separate tool with a GUI-based configuration to be able to have more powerful operations than maybe even what Git allows, would be, let's say, observability tools, our monitoring. Not all, it might be very, very powerful if I could do some of my monitoring configuration also in code, but there are a lot of components to application, infrastructure, cluster monitoring, observability, logging, error tracking. All of these components don't necessarily belong in Git. Similarly, whenever I'm doing any type of feature flagging, if I'm doing not just continuous delivery, but progressive delivery, where I'm serving different bits of code. Maybe I have a new feature and I want to serve it to a part of my user base, or I want to give different people within the user base different experiences, depending on how their parameters are set, and I'm using feature flags to enact all of this. That can be pretty cumbersome to manage all within a Git structure. And having a separate GUI-based tool to do that is maybe another good place where maybe it doesn't belong in Git. And of course, something like incident management. When things do go down and we want to gather, investigate, do our forensics, remediate that problem, and discover how we can change things so that it doesn't happen again, that type of incident management flow needs a whole set of tooling and a whole set of practices that are probably outside of just having a Git repository. Although certainly having a lot of things in code and using code and Git practices within your incident management flow can be very powerful. But these are just a few examples that come to mind of how not everything belongs in Git. And so even though I personally love GitOps and I'm very excited about it, there are still some things that just don't belong in Git, and that's okay. Use the right tool for the job and use it where it's most powerful. So thanks for hanging with me through most of this video. Would love to see any comments, any tweets, or as we evolve this discussion, please go ahead and weigh in on this video or online. And just to kind of wrap up what we've covered here, we talked about what is GitOps. GitOps is going to be your infrastructure as code, or X as code, using merge requests as your agent of change. and you're applying those changes via automation, CI/CD. GitOps brings a lot of powerful benefits to you with a lot of struggles of infrastructure in the past and modern struggles that are emerging. Using GitOps as a practice can help you address these challenges, can help mitigate the risks, can help you be more productive and move faster and at a more stable rate. And we've talked a little bit about what your team structures can look like, what technologies you need to investigate, and even some of the roadblocks you might be facing that you may need to overcome on your GitOps journey. So with all of that, I want to say thank you very much, and we will catch you next time.